number of stormwater management projects over the last several years in the Three Bays area. And we felt that it would be a good idea to have representatives of those organizations come and talk about those projects that have been installed, what the progress on them is, what the expectation is for what they will do, and also to talk a little bit about potential educational opportunities at the library, and then what might lie in store for future projects. So without any further ado, I would like to turn the evening over to April Wobst of the Association to Preserve Cape Cod, and she and her colleagues will take us through the discussion about these projects. So April, have at it.
Just share my screen here. Thanks, Jim, and thanks everyone for hosting us again. Don't recall the last time we did an update. So I'm going to give kind of a general overview about the project and run through some updates on the work that we've done to date, and including some of the most recent work this spring, as well as what's coming up. Also on the call today, we have, I saw Nathan Collins, who's our newer town representative from the town of Barnesville. He's the new assistant engineer for the town, who took Dale Sodd's place for the project team when she retired last year. Michelle West from Horsley Witten Group, from the engineering firm we've been working with, as well as Antonia from the Cotuit Library, which is one of the sites of our newest installations. So again, this is a project aimed at cleaning up the bays through stormwater management. So very briefly again, just so we're all on the same page, what is stormwater? This is kind of rain or snow melt that's coming off of our hard impervious surfaces, things like rooftops and driveways, roadways, sidewalks, and to some degree also our lawns, which tend to be very compacted if they're primarily a big grassy lawn. So all of those we consider relatively impervious surface, meaning that the water cannot readily soak into it. So it instead runs off into our waterways, our streams, our ponds, coastal waters, or into storm drains, where it then gets some pre-treatment and then out into the waterways. So the goal of our project is to treat more of the pollution and remove that from that runoff. So not just getting at some of the garbage, oil and grease, but particularly nutrients and bacteria which are causing problems in our waterway. And our approach to doing that is installing systems like this that you can see in the picture on the lower right here, which is a green infrastructure system at Prince Cove Marina, which uses plants and soil media to really get at, in particular, removal of that bacteria and the nutrients like nitrogen and phosphorus. So again, that's important because those extra nutrients, when they get into the waterway, they cause things like algal blooms. Those excess algae blooms, when they die off, can cause fish kills. Bacteria causes shellfish and beach closures. And again, so that none of that's good for kind of our local recreation or economy. So all of these are a piece of trying to address that water quality problem. So this is a 5-year project that got underway late in 2016. In total, currently it's now at a $2 million total project cost, which includes $1.7 million that we've gotten through state and federal grants. So APCC has been managing these federal grants. We've been successful in getting 3 different EPA Southeast New England program grants. And the town has been awarded now a 4th state grant through the Office of Coastal Zone Management. And then the project team has also been providing in-kind contributions of about $300,000. So it's a very significant project. We started with just 1 federal grant back in 2016. And from the success of that has continued to build and get more funding to expand the scope of what we're doing. So the approach we've taken is looking at starting with a watershed assessment and prioritization. With the funding that we've gotten.
April, if I could just interrupt for 1 second.
Yep.
If people have their mics open, it would really help us a lot if you would close them and mute yourself, because we're starting to get a lot of feedback. Thank you.
Yep, thanks, Jim. So we started with phase 1 with our initial funding, going through looking at the lower part of the 3 Bays watershed. This is kind of Route 28 here. So we looked at everything south of that to see where there might be space to put in these kind of green infrastructure systems to help remove pollutants from runoff. So we did that initial assessment in 2017, then worked our way through design and permitting, with initial installation of sites fall of 2018 through spring of 2019. And then with some additional grant funding, we were able to kind of start phase 2. Our assessment moved up a lot of the waterways, so up the Marshall Mills River, up Little River, and then also kind of in other parts of the watershed north of Route 28. So again, look at further away from the bays where we might put in more systems, and then again, multiple phases of design, permitting. And then we finished just some more construction this spring, and we have now some funding for additional construction next year. So in total, again, this map here shows the lower 3 Bays watershed, are surrounded in pink. With that assessment work, we now have for the town a watershed plan that looks at and ranks 71 different potential stormwater retrofit sites. And each of those are prioritized by things like feasibility, estimated cost, maintenance burdens, education opportunities, things along those lines. So everything kind of here, again, south of Route 28 was from that initial assessment, and then these others were from the secondary assessment. Now, this doesn't mean that we're expecting the town is going to go one by one and do all 71 of those projects. Some of them over time we've determined are not really feasible, or the challenges outweigh the benefits for those. But this does provide kind of an ongoing list that we've been building from for looking at new locations for building these stormwater systems. So to date, we've completed design, permitting, and construction of systems at these 6 locations. The first 2, Cordwood and Prince Cove, we did over kind of the winter of 2018 into 2019. So Cordwood Landing here and Prince Cove up here. Ropes Beach, with some additional funding, we began in the spring of 2019 and finished in the fall of last year. And then this spring, we did construction at Cotuit Library, Putnam Avenue, and started some of the work here at South County Road. And this is the site here where we're going to finish some additional construction with new funding next spring. In addition to that, we also did some early design. Sorry, I'm hearing a little feedback. Again, if anyone is not muted, if you could go ahead and do that. 2 other sites here over in Osterville, where we did some early concept designs. We had some kind of challenges with those sites, and so with the timing and funding for the project, we left those at concept designs. Those could be further developed in the future. I think many of you are familiar with, we did permit level designs for a site right at the very end of Little River Landing, which we ran into issues in terms of the design and couldn't find an alternative that fits there for right now. So the systems that I'll talk about up here at Putnam Avenue, up Little River, were kind of the alternatives that we have developed and actually constructed as an alternative to what we'd initially planned here. And then the last sites are further up Marston Mills River. There was a series we looked at here, 2 that we did through concept design, and the last one up near Rosa Lane, which we've actually finished permitting and design for, and could seek additional funding for construction in the future. Route 28 is a really big road. Unfortunately, it's a little bit outside of the scope of our project because it's state-owned route, and the expense as well as the partnership there kind of goes beyond the scope of our project. But there is a town-owned piece right at Route 149 and Route 28 that the town already has constructed, where we've looked at some potential maintenance improvements. So I'm going to quickly go through the first ones that we've already talked about in past ones, and then some of the most recent constructed, mostly with pictures. So hopefully that'll be kind of interesting. So Cordwood Landing, this is one again that we constructed 2018 into early 2019. This is an existing system that was already there that we worked to do improvements on. Not enough of the water from the main roadway and this road going down to the landing was actually making it into the system. So it was designed out to put in these inverted broad dips. It's kind of like an inverted speed bump to direct water into the system. You can kind of see them a little bit more here in the after picture, and then stabilizing the sides of these steep slopes and putting in this structure here, which is called a forebay. So the way these systems work is you try and get the water in them, and then through the soils and the plants, you allow that water to soak in, and beneath the ground, you're able to get a lot of that bacteria and nutrient removal. The problem is if you get too much of these fine sediments, it clogs it up. You know, you want the water to soak in. So putting in these forebays allows a space for you to collect and remove that sediment before it gets into the planted area, clogging it up and making that system stop work over time. So that was kind of the improvements we did to the existing system. And then at the very end of the landing, where you access the water, we went through and removed all of this excess vegetation. This parking space was moved over. This is kind of a different angle where the new parking space is, where this truck is. And in here is a kind of depression, a small bioretention that was planted out. And then the access was stabilized with porous pave. And again, one of those inverted dips directing water into a sediment forebay. So a lot of the problems we saw here at this site was a lot of erosion of that sediment, and sediment tends to hold, bacteria clings to that. So by stabilizing it, not only we're improving access, but we're preventing a lot of that sediment and bacteria from washing into the water, and we're redirecting the water into this bioretention that can help treat and remove that bacteria and nutrients. Prince Cove site, this is located right at the marina. So this is the edge of the parking lot, the landing and further parking is over here. Water was coming down the roadway, and from that going kind of down the road and then into the wetlands directly. And then there's this land that we saw here that Barnstable Land Trust owns. So we partnered with them and also worked very closely with the neighbor who lives over here and put in a sand filter. So this is what it looks like as it was going into the ground, and then that gets covered up. Again, there's a large sediment forebay. As you can see, there's a lot of sediment that was building up here. So this is a larger system to capture and remove that so it doesn't get into the planted area behind. So the water flows in over this little area and into this nice planted kind of meadow space where, again, the plants in the soil with the sand filter beneath are able to remove most of that pollution, any excess water once treated or continues off into the wetland behind. And then at Ropes Beach, again, there was an existing system here. As you come down, think of this as kind of, as you get down towards the parking, you need to go down Old Shore Road. There's catch basins upstream, so storm drains that capture a lot of that water, put it underground and into these existing little pocket wetlands off to the side behind the fence. This system was put in many years ago and really just needed some additional maintenance. So fixing this kind of bad connection of the pipe and flushing it out, you can see it was full of sediment in the under drain pipe. So you won't see overflow water going into this. All of that goes underground and then further down. And then the new system that we put in last year is right along the wall right by the beach. So this is that wall right by the beach where all the parking is. So the design there was to move the parking spaces back and put in a recessed chamber gravel wetland right against that wall. So we were lucky to get some additional funds in 2019 to start this work in the spring. Unfortunately, with the contracting and getting everything ready, it took a lot longer to get it prepared. So as we finally started getting this specialty precast trench delivered, we ran into an issue. The retaining wall here, we ended up having a crack in. It wasn't as stabilized as we expected. It didn't have any rebar in it, which there's no way for us to tell. So ultimately, we made a decision to stop and halt construction because we were getting into the summer season, and then this was finished in the fall. So last fall, they built a new retaining wall, and then the precast trench was put in along that wall, filled with the gravel. And here is kind of the structural part of that forebay, like you've seen in others of the systems. So the idea is the water comes down Old Shore Road. This is where the cars kind of can pull up to that system. Water goes into a small trench here, piped underground, and then up through the system, through the bottom. So there's a small amount of potential ponding of water just above the gravel surface, and then plants there. And again, it's all recessed, it's even with the parking lot. So this was kind of the example of what we were designing it off of. But at this location, we wanted people to be able to walk straight over because we know people essentially access from that parking right over to the beach. So the other area that we saw a lot of erosion, this is the path as it used to be. We needed a place for overflow of water from our system from the big storms, and we wanted to kind of reduce that erosion. So we put in these steps that infiltrate and allow the water to soak in. So there's the kind of different stages of those being constructed. And this is kind of the side angle of that trench with the steps going down this way. The town has also taken some steps to remove or relocate the end of this path, because again, I know there's been a lot of issues since then still with erosion down at the end of the path. And then this again is what the final trench looks like, again, covered with a grate. So you can see there's salt marsh tolerant plants underneath, planted in that gravel, and then these trench grates covering it. Cars can pull straight up, people can walk right over, the plants get enough light and they can grow through that system. So it's a really kind of unique way to fit a storm water treatment system in a very popular, busy place where there's not a lot of space. So with that, I'm gonna pause and see if Michelle, West, or Nathan have any specific comments about kind of the design and function of those sites before I go on to the ones we just constructed this spring. Nothing for those? Okay.
Yeah, I think you covered it. Thank you.
All right, thanks, Michelle. So this spring we had put out to bid to do construction at 3 new sites. The first one was the Cotuit Library, and because we already had it out to bid, we were ready to go with construction despite all of the closures for COVID. And in fact, we were actually able to get in and out of this site more quickly because the library was closed. We were able to access through the parking lot. But at this location, you can see here in the bottom right, this pink surrounds the area of kind of where we're collecting water from. So most of the parking lot, as well as about half of the building's roof runoff. So coming out of their gutters and down the roadway. And then we designed in this garden space to fit right in here in between the end of the parking and the playground. So this was the early concept design. And you'll see from the pictures, the end garden looks much like this. So the water would flow off of the paved area and into this garden, kind of twisting and turning around. And the idea with this location is that it gives us a lot of opportunity to work with the community, work with the library, and provide more education, outreach, and programming. So it was designed to be very interactive and kind of more aesthetically pleasing, whereas some of the others we keep very basic with their plantings to make it easier maintenance. So, you know, putting in logs and stepping stones for people to walk through, benches, so you can really interact with the garden. And then this concept also shows kind of painting that could be done across the parking lot to kind of show the flow of water. And that's one of the things that is still planned to kind of be done. There's other different types of design elements that we didn't include in the early construction, with things like putting in a cistern to capture more rainwater and a hand pump to allow people to kind of let water flow and watch it go into the system. But the design does allow for added elements like that in the future to do more programming. So this is what it looked like under construction this spring. So this is as it was excavated. Again, here's the library. This is kind of where the existing path through the park goes, and the playground over here to the left. This is looking straight up from the playground. Again, those stepping stones going through. So again, it's meant to be very interactive. And then kind of as it was being planted, so you can kind of see there's the water will enter here and flow down and around. And there's little logs that you can walk across and stones. And this is kind of early after it was planted. So with this site, again, this is one that we picked not only because of the ability to improve and clean up the water, but to work with the library. So I'm going to turn it over to Antonia to speak briefly about some of the planned activities that they have that we're going to be working with them on over the next year or two.
Well, we were able to get a LSTA grant, which is a federal grant administered by the Massachusetts Board of Library Commissioners, specifically for educational programming around gardens in libraries. And we decided to try and do sort of multiple levels of programming depending on people's preferred interaction with the library itself. So there's going to be programming that people can do independently of coming to the library, just visiting the garden, and that's going to have to do with signage and you know, things that they might be able to access online. And then there's going to be monitoring equipment in the garden that will measure things like water flow and soil moisture and things like that. And we'll have a public dashboard with that information on a computer screen. Then we have, for adults or older patrons, we're going to be doing a series of workshops and lectures. At the moment, we're trying to figure out whether we want to do things by Zoom or whether we want to wait until we can do live talks on topics like improving your own lawn care in an environmentally friendly way, safe boat or clean boating practices, various topics that are related to conservation. And then for children, we will be doing different ecology workshops that we are working with actually April's intern, the APCC's intern, Melissa, and with my youth services librarian, Lisa, who is also in on this meeting, to finalize. Right now, they'll probably be largely take-home kits until we can do more actual in-person programming. But we will also be using the garden to do story hours that are related to water conservation themes and environmental themes. We have a story walk planned. You may have noticed that there's one in the front lawn of the library right now, but we'll do something that we have a book that's specific to water that we can put up around the garden. We have some intergenerational programming, everything from creating fairy gardens and also creating models of filtration systems. So all of these things are in the works. It's right now where we're working with the MBLC to adjust some of the schedules for that, and maybe adapt some of the programming to be able to carry it out now in an era when we're not able to do as much in-person programming.
Antonia. Yeah, so this site again was a really great opportunity for education outreach. So we have an interpretive sign that's getting finalized that'll go in there soon. And with some of the grants that we have, education outreach is a big component. So APCC and Horsley Witten will be supporting and working with the library on several of these different activities. Michelle, did you want to speak a little bit more about the design and function of this system?
Sorry, had to unmute. We are really excited about how this turned out. As April mentioned, it does look very similar to the early concepts that we had for this, and it just came together really well. So we're hoping that people are already out there enjoying it. And we did see some kids walking through and even finding a good spot to perch and read a book. So that was really exciting. But basically this flows in, as April said, into a pre-treatment area that's easily maintained. It has a hard bottom, so sediment and other trash can be scooped out. And then it flows through a series of cascading bioretention cells where the stormwater can soak in and be filtered by the soil below and the plants on top. We used a variety of shade tolerant native plants here, and that is some information that we'll make sure that Antonia has and can work into the programming as well, so that people can learn. A lot of these you see that are in more sunny locations, so the plants will look different. Prince Cove, for example, if anyone's been out there, has very sun-loving type plants there, whereas these will be much different, and it'll be fun to watch it grow. And then when the water does fill the bioretention area, it flows into an overflow structure that I'm not sure, it is in this bottom right photo. And that actually is connected to 2 dry wells. So we get additional infiltration from this system. And then for really large storms, it will continue to go where it always went before, which is kind of down to the back corner. So I think that's pretty much it.
The other main site that we did a lot of construction on this spring, again, was along Putnam Avenue, so further up Little River from the original site that we had done some design work there. So there's two systems that went in here. One is a bioretention right here at the corner of Putnam Avenue and Captain Isaiah's, and then a larger dry soil here along the side of the road. So again, these areas in pink show the area of drainage, so where we're collecting water to go into those systems. So it's a pretty big 4.1 acre drainage area that we're collecting at this location. And this is again showing that in close up. So here's the corner of Putnam and Captain Isaiah's, showing again here on the design plan the area for treatment. And then along the road here where we put in this dry swale in this location here. And then this is where Little River crosses. So at this location, all of the water that was flowing down Putnam Avenue was just going completely untreated through kind of a paved flume into Little River. So Michelle, if you want to speak to kind of the design for this spot, and then I'll show the final photos of what that looked like.
Sure. So the design here was to try to capture that runoff off the road before it reached that most down gradient point right next to the river. So we designed these paved flumes further up the road to intercept that water and bring it into a swale between the main road and the spur road. These are what we'd call dry swales. They're very similar to bioretentions, but we tend to plant them with more just grasses. And the water will filter into the soil below. We have nice sandy soil here. And it's another cascading system just because there was some slope there already. So we try to keep the swale as flat as possible. And we break up the cells with little check dams to help us meet that grade. And then at the very end, it flows into any overflows from large storm events will then enter Little River in that same location that it used to go before. But the majority of the very dirty water from the first 1 inch or so of rain will have been treated.
Yeah, so these are just some photos of what it looked like during construction, the corner, small bioretention, and this is kind of just post-planting. This large boulder at request of kind of the neighboring association has been moved or is going to be moved back here with some further plantings put in, but again, fencing just around the edge to kind of protect and delineate the edge of that. And again, this is the swale as it was being constructed and just after it was planted. So there's a lot more grasses growing in here as well as weeds. One thing I do want to point out for both of these sites that have plantings in them, we're still in kind of the first year post-construction contract with the company that installed these. So this first year is when the construction company will be going in and doing the maintenance of the plants and the systems. They're under contract to do that to make sure that they continue to function. But we are already working on scheduling a maintenance training with the town for these new locations to happen this fall. So again, the town will get trained in how each of these systems function, and then they will take over officially all of the maintenance next year. And then the last site that we've worked on some construction on is up South County Road. And this is kind of a small ponding area. So this is the roadway here. There's a small ponding area just to the northeast, and then this kind of unnamed channel that goes down into Warren's Cove. And this site was picked because Warren's Cove is one of the kind of most polluted areas within these bays and the water bodies. And this location is one that Barnstable Clean Water Coalition has done sampling of and has found some of the highest nutrient levels during storm events. So this was one that we were very interested in working on. Again, this pink area shows kind of the drainage area, which is a total of 4.7 acres that would be treated with the installation of kind of 2 dry swales, a small one here to the northwest and a series of small ones here kind of on the northeast. And then again, this is the kind of rough stream that goes through. And at this location right here is where we put in what's called a water quality unit. So when we put the project out to bid this past winter, we weren't sure if we were going to have funding to construct all of these. So with the funding that we had at the time, this water quality unit was the only piece that we put in. But the town has just been awarded additional funding. So the plan is for next spring to install these dry swales along this edge here. And again, those dry swales will look very similar to kind of what was installed along the edge of the road at Putnam Avenue. So I'm going to turn over to Michelle again just to talk briefly about the design of this system and series of pieces that we're going to go in here.
Sure. So the upper graphic here is that small swale that April just mentioned. And in this location, we're going to do something similar to Putnam, where we are intercepting the flow from the road with a paved flume before it has a chance to go into the catch basin that's right next. That's the kind of orangish yellow circle is an existing catch basin. So this road is different from Putnam in that there's already a drainage network. There's a series of catch basins, manholes connected with a drainage pipe that discharges, has a specific outfall into that stream that she was just mentioning. So we're trying to get the runoff before it enters that network, because once it gets down into the pipe, it's already lower than ground level, and it makes it much more difficult to treat it with these effective surface practices that we're using here. So we're going to capture that before it enters the catch basin for small storms and treat it with, I believe there's 4 cells there for the dry swale. And then any overflows that don't infiltrate and be treated with the soil will flow back into the drainage network, as April's showing right now.
Michelle, to help orient people, somebody's
Yes.
asked, what is the cross street on South County Road?
There we go. That is
Right here.
28.
Okay.
Yep. So yeah, so it's just a little bit southeast of Route 28.
Thanks.
All right. So then that lower graphic is just showing the water quality treatment unit that we already installed this spring. And so this is basically like a manhole, but it provides extra removal of heavier sediment and trash, and some floatables like oils in this structure. And then the town crews can come and clean that out. So it's not as effective for bacteria and nutrients like some of the other practices we're showing, but it does provide a minimal amount of treatment for a much larger drainage area. And since we couldn't treat everything in this area, we decided that it would make sense to at least have this minimal treatment here. And then that larger swale is actually a broken up series of 3 different swale groupings. And in this case, the swale is more complicated than at Putnam because the water is in that pipe, and that pipe is the orangish yellow line at the bottom, yes, as April's pointing to. So it's on the other side of the road, but on that side of the road, we had a sidewalk and we didn't have a lot of space. So we needed to capture that runoff and bring it across the road into our swale system. So we do that with a pipe in a couple locations. And we also have infiltration chambers, leaching chambers in that bottom cell that are shown in brown there to provide some extra treatment before any larger storms flow back into the drainage network.
So again, these swales are what we're planning to put in next spring. So we'll be going out to bid for construction next spring for those. And then the last site that we'll just touch on really quickly, this is one that we've completed design and permitting for early into spring of this year. And so this is to look at addressing some of the runoff that's coming off of River Road and into kind of wetlands that connect directly to the Marston Mills River. Again, that was another location, particularly where the road intersects the Marston Mills River, where Barnstable Clean Water Coalition has captured some information about pretty high nutrient levels in particular with after storm events from the runoff. So again, here's the drainage area. And again, this is another dry swale to go in along the edge of the roadway. So there's this space that was identified along the edge of the road where we could put something. However, as we got further along in design, I think it got much more complicated. These lines, I believe, Michelle can correct me, are water and gas lines. So this is kind of the little space along the road where we intend to put the dry swales. And so the design is to work its way around those existing utilities. For some degree, this one we have kind of put at a later stage for construction just due to the complexity of design and construction for this site. But again, it's a dry swale system. You can see these two kind of green sections. This is, again, another system that would go right in along there, kind of fitting around where those existing water and gas lines are. Anything else on this site, Michelle?
This also has some additional infiltration chambers in that bottom cell for added treatment.
So again, operation and maintenance plans are a piece of this. Again, the town kind of maintains ownership over all of these. So we've already done several trainings and there's specific plans for each of these. This is kind of excerpts of some of the plans from the Prince Cove site that show kind of areas very, very clearly where the town can mow and can't mow, and kind of basic steps to walk through. So again, we have additional trainings planned for the new locations that were just constructed. So in total, kind of the impact of the work that we've done to date is development of this kind of watershed stormwater management plan that we've been continuing to kind of tick off different high priority projects on in terms of design, maintenance, and construction. We did the improvements on those 2 existing systems at Cordwood and Ropes and have now installed 6 new systems with those 2 additional dry swales planned for next year. So in total, we've addressed about 17 acres of drainage area. And then with each of these systems, you know, I had these numbers in there on several of the slides. They've all kind of are designed to minimally kind of capture and remove 50% or more of the nitrogen and about 70% of bacteria. They're each kind of different types of systems. So some do better with bacteria or nutrient removals than other, but overall, each of them are kind of hitting these kind of minimum marks. And again, these are the key pollutants that we're really focused on kind of removing. So we've done some really early maintenance trainings for the town, both Barnstable and across the Cape, because these are still relatively new systems. There aren't that many of them around the Cape. And so we've really been working with the towns across the Cape to kind of show them kind of how these systems function and work. And APCC and Horsley Witten are actually working with the town of Eastham on some stormwater projects like these right now around Schoolhouse Minister's Pond. We did some trainings last spring and fall. We'll do another one this fall, and then hopefully as well next year after we get the final installations put into place. So I think with that, that covers kind of where we are, and if there are any questions,
yeah, I've got a number of them have come through, April. I'm just going to go in order that they came, and as more come in, we'll go to those too. So the first question is, did you include undeveloped private land in your watershed plan for possible site development?
That's a good question. So with the funding that we have, the state and federal grants are primarily targeting public lands. So that was the main area that we looked at assessment. That being said, as some of the work was done when there were like clear opportunities on some private roads and properties, we do have some of those identified. So for example, the Bridge Street location is right along the edge of the right-of-way, which is town-owned and kind of overlaps a little bit onto private property. And there are some others that were also identified, but it was primarily public lands because that's the way the grant funding was focused.
Next question is, where did the contaminants that are captured go after they collect under the grates or in the systems?
I'll touch on that briefly and then I'll let Michelle talk about it. So really the bacteria and the nutrients are broken down. So within these systems, you create kind of underneath both kind of the soil microbia and this anoxic conditions that allow you to break down the nitrogen and break down the bacteria into kind of unharmful conditions. So they are being broken down into other forms, and some of that nutrients, some of that goes back into nitrogen in the atmosphere. Some of it's taken up by the plants. Michelle, you can speak to that in a more technical perspective.
I think that was great for bacteria and nutrients. And then just thinking about the pretreatment structures, whether it's under that trench drain that's in the parking lot at Ropes or in the forebays at some of the other practices, those heavier sediments or perhaps trash, maybe some leaves, that sort of thing, that's something that will get removed from the DPW's maintenance and will be hauled away. So there's the smaller kind of dissolved pollutants that get taken up by the systems themselves and broken down, and then those larger contaminants get taken away from the site.
Okay. Was South Old Shore Road looked at for stormwater drainage and mitigation at the boat ramp?
Yes, that is one of the sites that we looked at, and we actually had identified some concept designs right along the side. With some of our early meetings, I think back in 2017, that was one of our kind of 10 sites that we reviewed with the public. I think the challenge with that location in particular is that a lot of that space along the side of the road is used for vehicles and their trailers getting in and out of that boat landing. So when we kind of came down to the amount of space that was actually potentially available to use, it was just very limited. There is, however, the town does have a system, if you kind of look along that, and we do have it in kind of a walking tour guide to stormwater systems. There are some catch basins going down. As you go down the hillside, you would drive up it, but catch basins along the side that link up to some underground lava rock system that does some treatment removal there. But again, we did look at if there was something we could do closer to that landing, and there's not a lot of space there. So that one, based on input that we received early in the project, was not one we developed further.
Okay. Someone wants to know the name of the vendor you're using for the interpretive sign because they need one for a project they're working on.
We're currently looking at Paneer, but I know that there are other vendors as well that make nice signs, but we've had good luck with Paneer. That's who we'll be pursuing.
Okay. Two related questions. It seems like there's runoff everywhere. How do you select locations? The related second question is, I noted a big dig to fix a storm sewer at Lewis Pond Road and High Street. Is there an opportunity to piggyback on those kinds of projects?
Michelle, do you want to talk a little bit about more of the factors that you guys took into account when you were looking at locations for retrofits in our prioritization?
Sure. It's true, runoff's everywhere. It can't all be that bad. And all of it's not necessarily. But these are locations where the runoff directly from those roads and the fertilizers from lawns and all of those pollutants that April mentioned earlier are being directed specifically with an outfall pipe or a paved chute into our water bodies that are impaired. And so that was part of our ranking criteria as we worked our way through the watershed. There was no mitigating factor, no grassy area, no woods, no like open area for the water to soak in and be treated. It was a direct connection to our waters of concern, and that helped us prioritize. And then I think the other question, I'm not exactly sure of the site that they're talking about, but absolutely we should be taking advantage of other projects in town that maybe aren't stormwater related, but maybe you could work in a stormwater project while you're doing it. And that's part of why we have the larger set of sites. April mentioned, we're not going to go out and build 71 of these retrofits right away, but the town has that list, and they can be opportunistic about actually implementing them, even if they weren't high of feasibility for us to break ground and do it right now. If they're redoing the road or if they have another project in that area and they look at the list and say, oh, well, we also have a stormwater issue here, maybe we can do them both at the same time. I think that's a great opportunity.
Are you confident that that can actually happen? Is there coordination between who's deciding on the various projects? Do the people who are thinking about putting in a storm sewer even conscious of these various stormwater retention efforts? Or is it just siloed separately and never gets put together?
Nathan, would you
Nathan,
like to comment on
sure.
that?
Sure. From the town's perspective, anytime we kind of look at a project, whether it's sewer, water, stormwater, we always look at kind of what we can do while we have the road open as well. So as it relates to these specific projects, oftentimes there's time constraints. So for example, when we receive these grants, we have a window where we're able to do the design and construction. And in this particular area, you know, we've just been focusing on the stormwater, but these aren't the only stormwater efforts that the town is making. We currently have an annual allotment for stormwater repair around impaired ponds. And we also have an extensive program through our MS4 permit where we're monitoring catch basins that have direct outfalls. We're testing all our known outfalls for contaminants if there's flow. So we're doing everything in our power certainly to monitor and maintain the systems that we have in place.
Great, thanks. Beyond the treatment sites themselves, have you been able to measure the nitrogen and bacterial reduction in nearby water bodies?
So this is something that has been ongoing. The town, working with Barnstable Clean Water Coalition, does a lot of water quality sampling within the bays. So that's not something that we've taken on as an additional piece because that data is already there. So we are kind of looking at that over time. And then for each of these specific systems, you know, we looked at potentially including more detailed plans for monitoring at each of those sites. But a lot of these types of designs, you know, they've been well studied. You know, the UNH Stormwater Center has looked at these. They've been installed in other locations. And really the emphasis that we got from EPA is that if they're designed and well maintained, they will function as they are meant to. So those pollutant removal rates are pretty consistent once it's put in and if it's maintained. So we've really been putting a lot of emphasis, particularly on kind of more money going into construction and maintenance. And, you know, as I mentioned, we've had a series of maintenance trainings and we have many more planned. A lot of the design work, you know, all of this has been done in partnership with the town. So when we're looking at design and picking the plants and how it's set up, the design's been put in place to try and make it feasible and easy enough to do with maintenance for the town as well. So we're not doing any specific monitoring at these locations, but we have pretty good numbers based on what these systems are designed to do and the total area of water going into them to be able to say how much of the pollutants they're removing.
You folks may not have the answer to this, but do you happen to know if there is still a big open outfall pipe going into the ocean between Loop and Oregon Beach?
That one I don't know about. I don't
Okay.
recall that from our list either, but.
No, I don't think it was on the list.
Yeah, and from our end, I'd have to look at we have a map through our illicit detection program that logs and has a map of all the outfalls. So certainly if there is still one there, it was tested in the last year. But I would have to look at the map and have it in front of me to see if there's still one there.
Okay, thanks, Nathan. What you might, Nathan, if you could do that for us and maybe just get the information either to myself, Jim Dannha, or to April, and I can get that information out to people. That'd be great.
Certainly, I can look that up tomorrow.
Terrific, thanks. Antonia said she has to go, but if anybody has any questions about the library's educational plans, feel free to forward those questions to her via email, and she'll respond as soon as possible. We have a question. Is there a need for volunteer maintenance of any of these systems, or will the town manage all of them?
So I think some of these, particularly the library, is an opportunity for volunteers to assist. And the town has already been working with the Barnstable Association of Recreational Shellfishermen. They've already been doing maintenance at the Ropes Beach and Cordwood landing locations, particularly with some of the existing systems, but they also joined for the trainings last fall and I've been in touch with them this year as well. They've been doing some maintenance out there again at Ropes Beach and at Cordwood. So there are kind of key opportunities. The Putnam Avenue location as well is one where there's a neighborhood association that if there's the interest from them, that we could also work with them on some training. But I think of the locations now, like the library is very central to the community. If there's people who are interested in learning more about how to help maintain that, there are definitely parts of kind of the above ground maintenance of the plants and weeding, you know, removal of garbage and things like that, or notifying the town if they see any issues so that the town can come in and do some of the more detailed maintenance. There's definitely opportunity for that, and people are welcome to reach out to me or Antonia, for example, at the library if there's interest in that.
Great. Brian Horsley messages that the outfall pipe that was mentioned is the Rushy Marsh culvert pipe. It's not an outfall, but it's a tidal connection to a salt pond. He's not sure what the current status is. One last question. I think you've answered this, that you don't measure this, but what portion of the total nitrogen going into the harbors is being removed by these systems?
Yeah, so we're not measuring that directly, but there's been a lot of studies kind of looking into that. I believe, if I'm remembering correctly, for the Three Bays watershed, it's roughly about 25% of the nutrients in the Three Bays comes from a combination of stormwater and fertilizer use. Across the Cape, it averages closer to about 20% from kind of stormwater fertilizer use and 80% typically from septic. But in the Three Bays watershed, it's a little bit higher in terms of the portion from stormwater fertilizer combined uses. So again, septic systems, wastewater is still one of the main sources across the Cape. But these projects are kind of low-hanging fruit. They're relatively inexpensive, and they can help address a good portion of those nutrients that are going into the waters.
Great. Thanks, April. Well, those are the questions that we've had. On behalf of the association and the village, we do want to express our gratitude for all of the efforts that the team has put in getting these systems installed, and in always being ready to talk to us about what's going on and what the prospects are. So thanks to everybody from APCC, Horsley Witten, the town, and we hope to hear more about more successes in the future. So thanks a lot.
Yeah, thanks, Jim.
Thank you, everyone.
Thank you.
Okay, doke. So with that, I'm going to end the meeting. So thanks, everybody, and look forward to the next time.
Thank you.